Okay, so this is video 6, Unit 2, and we're going to say that again. This is Unit 6, Video 2, and we're going to be working on solving some trigonometric equations. Make sure you have your note sheet ready. I'm going to try 5 examples, and I'm going to leave 3 for you to try on your own using similar methods that we are going to use in these. Now, one thing I have to make sure is very clear here is that as you go through these, we are not restricted the same way when we were working with inverse functions to what quadrants everything can fall in. So we're back to using this familiar ASTC as to where the values are positive and negative. So that is what's going to have to be coming to your mind as we go through these problems, rather than the restrictions that we were using for the previous video on the arc values or inverse functions. Okay, so we're going to follow a process very similar to what you've done in algebra, except we're going to be using our trig values. And one of the things that's trig functions, one of the things very important is to remember you can never, ever, ever, ever divide by a trig function. It's absolutely illegal because the values could be 0 and we can never divide by 0. So we don't know what x is, so we can't divide by it. So we're going to avoid that at all costs. Let's go ahead and take a look here at number 1. To solve this and try to get the cotangent of x by itself, I'm going to subtract 1 from both sides, leaving me with 2 times the cotangent of x to equal -2. I'm going to divide both sides by 2, leaving me the cotangent of x to equal -1. Now, if I want to find out x, then what I want to find is what angle gives me a -1 for our cotangent. And I have to remember that cotangent is negative in quadrants 2 and 4. So I actually have 2 places where the cotangent will give me a -1 value. If cotangent is really cosine over sine, then I'm looking at this being a -1, so I want the same value in the numerator and the denominator. And the only place that we have both the numerator and the denominator to be the same is on our 45-degree angles. So I'm looking at my 45-degree angles that fall in both of these quadrants, because that will give me the cotangent to reduce to a -1. Well, cotangent, or the 45-degree angle located in quadrant 2 is 3/4 pi, and the angle given in quadrant 4 is 7/4 pi. If you're asking yourself or considering typing, do I have to do this in radians? My answer is yes, you must do this in radians. So please do not ask that as one of your comment questions. Number 2. Oh, sorry, those are my answers for x. My 2 values are 3 pi over 4 and 7 pi over 4. I was getting so excited I didn't answer the question. Next one, we're going to subtract 2, leaving me with the sine of x to equal +1. Well, there's actually one place on our coordinate unit circle here where the sine value will be +1. My sine value is +1 on a quadrantal angle up here, so x will equal pi over 2. Example 3. So here, again, it's like I have variables on both sides, so I'm going to want to move those around. So I'm going to subtract a secant of x, and I get 1 secant of x, or just secant x, plus 1 equals 3. Subtract 1, and I get the secant of x to equal 2. Now the secant of x equaling 2 says that it has to be positive, and since secant is the reciprocal of cosine, I remember that cosine is positive. Cosine, or secant, is positive in quadrants 1 and 4. So I know my answers are going to come from quadrants 1 and 4. But if secant equals 2, then I know that cosine is going to equal 1/2. Well, if cosine equals a half, this might be easier for me to think about. Where is cosine a half? What angle produces cosine to be 1/2? And that angle is our pi over 3, or 60 degrees if you're thinking like that. And then in quadrant 4, that angle is 5 pi over 3. And those are my two answers. All right, next up, I'm going to add 3 to the other side for this problem. And I'm left with tangent squared. So how can we solve that? Well, I can take the square root of both sides. When I take the square root of both sides, I am left with positive or negative root 3. So in this case, I'm looking for where is tangent positive or negative, and that happens to be all 4 quadrants. So this one is actually going to give me 4 different answers, whereas the last few I've had 1 or 2 answer. So I will have 4 different possible answers for where the tangent equals both positive root 3 and negative root 3. Well, if tangent of x equals root 3, then there must have been a denominator of 1. And I'm going to try to make you think a little bit outside the box here, and this is root 3 over 2 over 1/2, because those 2's would have disappeared. So that would mean that this is my sine value and that this is my cosine value. So where is that occurring? Well, this is saying that the sine is a root 3 over 2 and my cosine's 1/2. And that occurs at all of my 60-degree angles. So all of my answers here are going to be the 4 different 60-degree angles throughout the unit circle in radians. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And those are my 4 answers for number 4. All right, last one I'm going to do with you, and then I'm going to ask that you try 6, 7, and 8 on your own to bring to class tomorrow to get started. Here I'm going to introduce another way of solving, and that is the zero product property. My zero product property says that I take each of these 2 factors and I set them separately equal to 0 and I solve them. So I end up coming up with like 2 different small equations. I'm going to add 1 to the other side, and here I'm left with a question that says, where is cotangent equal to 1? Well, cotangent is positive in quadrants 1 and 3. And we already talked about if cotangent equals 1, that means the numerator and the denominator must have been the same. So that leaves me with like a root 2 over 2 over a root 2 over 2. That's the only place that they are the same. So my answers are pi over 4 and 5 pi over 4, because this is the first quadrant and the third quadrant. Okay, for this one, I'm going to subtract 1 to the other side and divide by the square root of 3. Now, if your first instinct is to rationalize, that's okay, but it's really unnecessary here because I'm looking for where cotangent's negative, and cotangent is negative in quadrants 2 and 4. And then I'm going to ask myself, where is the numerator a negative 1/2 and the denominator root 3 over 2, which makes this my cosine and this my sine? Now, I don't really care about the negative because the negative can move from the top or the bottom, but this says the cosine is 1/2, which I know is all of my pi over 3's, but I am restricted to quadrants 2 and 4, so that's 2/3 pi and 5/3 pi. So in this case, I actually have 4 separate answers. I have pi over 4 and 5 pi over 4, 2 pi over 3, and 5 pi over 3. So again, this one gave me 4 separate answers because I was dealing with 2 separate small equations. Please try numbers 6 to 8 on your own. You can use your comments as a way to check your answers amongst your classmates if you'd like.